Today we are going to learn the setting reaction of high copper alloys. Let's start. Basically we should know the composition of high copper alloys. The composition of high copper alloy is it contains silver, tin, copper and zinc. We should learn the percentage as well. It is very important to remember the percentage because as we know here it is silver, tin, copper and zinc. The copper content here is 13% in high copper alloys, whereas in low copper alloys the copper content is 2 to 5%. You can see here. And the silver content is 69%, tin is 17%, zinc is 1%. So it is very easy to remember. The contents or composition of high copper alloy is silver, tin, copper, zinc. The percentage are from increasing to decreasing order: 69%, 17%, 13% and 1%. I can tell you a easy way to remember this. Silver is 69. Okay. You can remember it as a round of 70, and 70 we can also pronounce it at 17. It is just to remember purpose. That's why you can remember silver as 69, GAG 69, it is 9, similar. Then 70, 17, so 69 and 17. And copper is 13%, zinc is 1%. Now we have to learn the setting reaction of it. As it is, we can see here. I'm referring the book of. I'm referring this basic dental materials book. I found it easy to learn. When the components are mixed, the mercury begins to dissolve the outer portion of the particles. Here we can see that when we mix all these components, the mercury here, it begins to dissolve the outer surface of all the particles. Okay. Now next line. Silver from the silver copper eutectic alloys particles and both silver and tin from the silver tin alloy particles enter the mercury. So what he is saying here is the silver from the silver copper eutectic alloy particles. Here the silver from the silver copper eutectic alloy particles and both the silver and tin from the silver tin alloy particles enter the mercury. As you can see here, the silver here and the silver and the tin here, they both start entering the matrix, this matrix, that is the mercury. The tin dissolved in the mercury reacts with the copper of the silver copper particles and forms the Cu6SN5 eta phase. That is, here the tin, here it is dissolved in the mercury and it reacts with the copper of the silver copper particles. From here the silver and the copper are released, from here the silver and the tins are released. Then from this from here the silver and tin, the silver is and the tin is released. From here the silver and the copper is released. Then this silver, this tin and this copper, they both react with each other and form an eta phase, that is AgCu. After that the eta crystals form around the unreacted silver copper particles. The eta crystals which are formed in this matrix, they go around this unreacted silver copper particles and they form a boundary over it. At the same time, the gamma 1 phase is also formed. As in the low copper alloys, gamma 1 surrounds everything, forming the matrix. Gamma 1, what is gamma 1? Gamma 1 is Ag2Hg3. Here you can see this Ag2Hg3. This phase is also formed with the eta phase. And after that, the gamma 2 phase is also formed here. The gamma 2 phase is the weakest phase and it is very weak resistance to corrosion. Therefore, to avoid the corrosion, we have to keep the copper content 13%. It should be more than 12% basically to lower the corrosion rate. Gamma 2 is also formed at the same time, but it is later replaced by eta. Thus, in admixed alloy, the undesirable gamma 2 is greatly reduced. Now, the reaction may be simplified as follows: Ag3SN, that is beta plus gamma. Ag3SN plus AgCu plus Hg. Ag3SN plus AgCu plus Hg. Hg, that is mercury. What does it forms? We know that the mercury starts to dissolve the outer surface of these particles. Now it forms Ag2Hg3. This Ag and this Hg, Ag2Hg3. Now Cu6SN5, that is eta. This Cu reacts with this Sn and it forms the CO6SN5, which we call as eta phase, and this is known as gamma 1 phase. And we know that this unreacted AgCO particles remain. Then therefore the remaining AgCu. So this is very easy reaction. Ag3SN, that is beta plus gamma, AgCu we call as eutectic, plus Hg forms Ag2Hg3 Cu6SN5 plus Ag3SN unreacted and AgCu unreacted. You have to just remember this names: AgSN, AgCu, AgSN. Then after that the mercury comes and dissolves it. Then the Ag3SN reacts with AgCu and this Hg, this mercury component, and it forms the Ag2Hg3 and Cu6SN5 and the remaining AgCu. Here we, as I told you, the gamma 2 phase is eliminated because we need at least 12% of the copper content. Now we will learn the microstructure of the set high copper admixed amalgam. The Cu6SN5, that is the these particles, eta particles, they surround the unreacted AgCu particles. The final set materials consist of core particles of unreacted AgSN alloy, that is gamma phase, and unreacted AgCu surrounded by halo of a Cu6SN, this one, and embedded in the matrix made up of gamma 1. This is the matrix, that is gamma 1, which is made up of Ag2Hg3. So in exams, if you make this diagram, it will be very helpful. I hope you found this reaction right now easy. Thank you so much for watching this video.